So this question number to prove that 9 sec square a minus 9 tan square a, we have to select one of the options that are given there. So take 9 here common. So we have sec square a minus tan square a inside, and this is an identity, right? Sec square a minus tan square a is 1. So replace with 1, we get 9 into 1, that is 9. So in the second part then, we've got 1 plus tan theta plus sec theta, 1 plus cot minus cosec. Now in the previous video I had shown that we can convert this tan and sec in terms of sine and cos. So if you remember that, tan will become sine by cos and sec will become 1 by cos. Here cot can be replaced with cos by sine and cosec can be replaced with 1 by sine, right? So this is replacement of the trigonometric ratios in terms of sine and cos. Now you're going to take the LCM here, cos theta. So this is going to become cos theta plus sine theta plus 1. Okay. Here already the denominator is cos theta. Here we'll have to multiply this, we get cos theta. Similarly here sine theta. So this will become sine theta plus cos theta minus 1 upon sine theta, right? LCM we are taking, 1 means 1 upon 1. Now you'll take the LCM here, cos theta sine theta. And this is in the form of a plus b, a minus b. Because see, if you look at this cos plus sine and cos plus sine, this is actually same. So this can be written as a plus b, a minus b. So we've got in the next step a square minus b square. So cos plus sine can be considered as a, right? So a square minus b square. Now if you're considering this as a, then cos theta plus sine theta whole square minus 1 square. So I need not write it as 1 square, let it remain as 1. Now this is an identity. This can be written as a square plus b square plus 2ab and minus 1 as it is. Now sine square plus cos square is 1. So I can replace it with 1. 1 and minus 1 cancels. We are left with 2 sine theta cos theta upon cos theta sine theta, right? So cos sine also gets cancelled and we get the option as 2. So the answer will be 2 here. Then we move on to the next question. Part number 3 and part number 4. Sec plus tan into 1 minus sine. So sec can be written as 1 by cos and tan can be written as sine upon cos. Take the LCM here cos, so the numerator gets added as it is 1 plus sine. So 1 plus sine into 1 minus sine, we get 1 minus sine square upon cos a. And we know that 1 minus sine square is cos square a. So cos square a upon cos a gets cancelled, we get cos a, right? Then 1 plus tan square by 1 plus cot square. Now this is an identity. What is 1 plus tan square? Can be replaced with sec square a, and 1 plus cot square can be replaced with cosec square a, right? So we get sec square upon cosec square. So sec square upon cosec square. Now this can be written as 1 upon cos square, and this can be written as 1 upon sine square, right? So 1 upon cos square by 1 by sine square, we get sine square by cos square. So final answer we get tan square. Okay, so sec can be converted as 1 by cos square and cosec can be converted as 1 by sine. So cosec square will become 1 upon sine square a. So when it goes up, it will become sine square upon 1. We have not written 1, but it's understood as 1. There's no need to write 1. So this becomes sine square by cos square, and therefore the result is tan square. Then question number 5 is proving of identities. Now, for proving of identities, we had in the last video I had given you some identities. We have to make use of this, and there are some rules which we have to follow. Let me first explain to you the rules. So the identities which we have already done was sine square theta plus cos square theta is 1, right? This is one identity. Then the other identity that we had discussed was sec square theta minus tan square theta is 1. And the other identity was cosec square theta minus cot square theta is 1. So these are the 3 identities which are there in the 10th course. Then I told you how to convert. Cosec can be written as cosec theta can be written as 1 by sine theta, sec theta can be written as 1 by cos theta. Okay, we are converting into sine cos. So tan theta can be written as sine theta by cos theta. And cot theta can be written as cos theta by sine theta. So whenever we get these trigonometric ratios, we can easily convert them. And there are some rules. These are not rules which are given in the books, but just by observation, I'm telling you. The first is always you need to convert your question in sine and cos. So convert into sine and cos. Whatever the question is, it works in 99% of the cases. Some questions are exceptions of all. Except for those exemptions, which I have, some exceptions are there, which I'll be discussing later. But otherwise, we can convert everything in terms of sine and cos. So first is convert everything into sine cos. Second step is to take the LCM. Okay, always take LCM. Third step is to apply identity. It could be an algebraic identity or it could be a trigonometric identity. And then after applying of the identity, you will take common and cancel whatever is coming common. And sometimes you will have to do a process called rationalization, which you did in class 9. That is rationalization of the denominator. Whenever there are roots, we do a process called rationalization. So let me explain to you a few questions based on this. If you look at the exercise, there is a fifth question based on the identities. So in these identities, you need to follow these steps, right? And when you apply these steps, you are going to get the answer. So if you look at the first question, you can take out there. Let me take out the first question there. So the first question is prove the following identities. This is question number 5. Prove the following identities where the angles involved are acute angles. Okay, so question number 5 is being discussed. The first part, cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. I need to prove this. So this is the LHS, this is the RHS. I need to prove that LHS equal to RHS. So I'm going to start with the LHS. Okay, that is cosec theta minus cot theta whole square. In place of cosec, I can replace it with 1 upon sine. So I'm going to replace this 1 by sine, right? We said that cosec is 1 by sine. So this is what I'm doing here. The first step, convert into sine cos. And cot can be replaced with cos upon sine. So clear, this is the first step, conversion into sine and cos. So once we do this first step, the second step is to take the LCM. So I'm going to the second step. We see that the denominator is same, that is sine theta. So the numerator will be written as it is, that is 1 minus cos theta. So in the second step, what are we getting? We are getting 1 minus cos theta upon sine theta whole square. Now don't disturb the numerator because this is what is required here, right? This is already required here. So I'm not going to disturb that. So this will be 1 minus cos theta whole square as it is. And denominator, when I square sine, I'm going to get sine square theta. And by identity, I know that sine square theta is, I'll shift here, this will become sine square theta is 1 minus cos square theta. So this will become 1 minus cos theta whole square upon sine square theta can be written as 1 minus cos square. Why am I doing this? Because I want cos in the denominator as well. So here we get 1 minus cos theta whole square as it is. Okay, so I have completed the first step, I have completed the second step. And now I have applied identity, sine square as 1 minus cos square. So this is the third step that we are doing. Now further, 1 minus cos square is in the form of a square minus b square, right? Because 1 can be written as 1 square also. So a square minus b square we can write as a plus b, a minus b. So in the next step, what am I going to do? I'm going to use the algebraic identity and replace 1 minus cos square as 1 plus cos into 1 minus cos. So what happens here? 1 minus cos theta whole square, that means it is 1 minus cos theta 2 times. 1 minus cos theta into 1 minus. So I'm going to cancel one of the 1 minus cos thetas. So you are left with 1 minus cos theta in the numerator and you are left with 1 plus cos theta in the denominator, and this is actually the same as your RHS. So therefore, what can we conclude? We can conclude that LHS is equal to RHS. So hope this is clear, and you can try out the other questions similarly, and you can watch my next videos to understand further how to do the next questions. So we'll be pausing.